Hi, I'm Stu from HiveMind Automation and welcome back to the Hive. In this video, I'm going to be completing a project that's been sitting in my backlog for months, and we're going to be putting an LED strip underneath the bar behind me, controlled by WLED. Now, since my last video on WLED, there's been a couple of updates to it. So I'm going to show you those improvements, and I'm also going to go over how I'm mounting these LED strips under the bar to make them look a bit nicer, as opposed to just sticking them up there and leaving them bare. So while I roll the intro, why don't you take a moment to subscribe and hit the bell icon to get notified when I release new videos each week. And let's get started. So behind me here where I sit and make these videos, we have a bar with some wall mounted shelves, and I've got a Mirabella Genio LED strip on top of those shelves. But for a while, I've been wanting to put an LED strip running along the underside of these cabinets so that we've got some nice ambient lighting down onto the knickknacks that we've got on the sideboard here, and also for preparing drinks in our bar when we have guests over, if that's ever allowed again. Now, as always, I decided that I was going to make things a bit difficult for myself and be extremely picky about what I wanted. I obviously didn't want the boring Mirabella LED strip with a single color across the whole strip. That being said, I have seen a Mirabella Genio strip that seems to use WS2812 LEDs, and if I can get my hands on one, I'll follow up on that in another video. But I also wanted an LED strip that had white LEDs as well as the RGB function. So, like in my previous LED strip videos, I opted for the SK6812s, and I'm going to be using those with a NodeMCU and WLED. Now, if you've not seen my previous LED strip videos, these SK6812s come on this flexible tape, and each LED has red, green, blue, and white outputs that we can control individually per LED, meaning we can have this one be red, this one be blue, this one be green, this one be white, and so on and so forth down the length of the strip. And with the right controller, we can of course change these quickly in succession to animate the strips. One of the great things about these strips as well is that they only need the 3 wires, no matter how long the strip is. We need to supply 5 volts, we need to supply a ground, and there's a digital in pin on the strip, and each LED has an out on one side which goes into the in on the next one, and so on and so forth. So they are controlled using a serial communication protocol. Now, the other thing with these strips is that in between each individual LED there are these lines, and you can cut them, and that's either the end of the strip, or you can get a dab of solder on there and then join some wires to go around the corner, or you can cut them, and you can also get some clips that will clip onto these contacts to go around corners as well. Now, to drive the LEDs, we're going to need a controller, and I'm going to be using this NodeMCU board, much like what we have done in the past with our LED control videos. And we're going to install open source firmware on this LED controller called WLED, as we have done before, but this time it's going to look a little bit different. And as in my past videos, I'm also going to be using my custom LED controller interface board that I designed and had the PCBs printed, so that we can use these screw down terminals to connect to the LED strip, and I've got that mounted inside a 3D printed enclosure that I also designed for that. This just helps us to put power in there. I've got a capacitor for some power smoothing. I have a MOSFET to control the power on off to the LED strip as well, and there are mounting points here that take the NodeMCU, and then the PCB just has power and ground for the NodeMCU as well, and then off to the gate of the MOSFET and also the driver pin of the output there. Now, to help me mount the LED strips, I bought this aluminium LED strip channel from a company called the Lighting Outlet, and I'll be sure to put a link to their website in the video description down below. This channel, I believe it cost me about $90. There was some shipping involved as well, but it arrived super quickly, and it's perfect for what I need. It's 3 meters long, and that is exactly the same length as the cabinets behind me. And it's a single piece rather than being multiple pieces that I would have to join together, which I have done in the past with previous LED strip projects. And as you can see, it is the perfect width to hold the LED strips inside the channel. The channel came with some mounting hardware, and I don't want to mount the strip right up against the wall. I want to put a little bit of space between the wall and the strip to improve the way that the light bounces off the wall. So to ensure everything's mounted the same distance from the wall to the mounting clip, I used an offcut of timber that was about 2 inches wide to butt each clip up against to ensure I've got an even spacing across the full 3 meter length of the strip. Now, after mounting the clips, I was also ready to cut the LED strip to length and then do a dry fit into the LED channel. Now, for me, I was very lucky. You see, these strips are actually shorter LED strips that are then soldered together about every 30 LEDs or so. And my 3 meter strip just happened to end on one of those solder joints. So all I needed to do was just desolder the joint, and I had the right length strip. We also need to know exactly how many LEDs are in our strip for WLED when we're setting up the software later on. Now, I happen to know that this channel is 3 meters long, and I double checked that, I measured it. And this LED strip is also 60 LEDs per meter, which, if my calculations are correct, 3 times 60 is 180 LEDs. But I counted them anyway, and it came out to 180. Perfect. Now, I haven't yet got the NodeMCU installed into the control board because I'm going to need to install WLED on the controller. So let's take a moment to do that now. Okay, so to install WLED, there's actually a new way that we can do this, and that is using this install.wled.me page. And this utilizes a tool called ESP Web Tools. And this was created by the team at Nabukasa, the people who maintain Home Assistant and run Home Assistant Cloud. It's actually a really awesome tool. So what we need to do here is plug in our ESP to a USB port, and that's what we're going to install WLED 012 onto. So I've plugged in, so I've got my NodeMCU plugged in here. I'm going to hit install and select the correct COM port. So we'll click install, and we want to use the USB 2 serial, which is this 14340. I'm going to connect to that. We're initializing and preparing. It's erasing the device. It's an ESP8266. Okay, our light is on. It says it's all done. How easy was that? We've got WLED installed on this NodeMCU. So what I'm going to do now is I'm going to click on the Wi-Fi logo here, and we'll see that we've got a WLED AP here. It's showing up because I have used that network before. So I'm going to hit the WLED AP. and then we will get the captive portal. So we're going to connect the module to our local Wi-Fi. So we'll go to Wi-Fi settings, and I'm going to put in details of my network. I'm going to put it onto the HiveMind automation network, and the network password. The MDNS address here, I'm going to copy that because that's going to make it a lot easier for me a little bit later on. And we'll scroll through here. We don't need to modify any of the access point details. I'm not going to disable Wi-Fi sleep for now. And I'm just going to hit save and connect, and we'll hit send on that. And what we should get is it should connect back to the Wi-Fi, and there it is. So it's connected, and we've got the controls here. So what I'm going to do is I'm going to open LAN scan, and I'm going to scan my network, and I'm going to paste in that address that we copied before, and we're on 192.168.174. So if I go to 192.168.1.174, we have the WLED GUI here. Now I need to make a couple of changes to the configuration here in order to make this work with my control board, because by default WLED is going to be looking at different pins for the LED controller and different pins for the MOSFET, and the MOSFET behavior might be wrong. So I'm going to hit config, and we're going to go to LED preferences. I'm going to put in our total LED count. We'll put in 180. It recommends a 5 volt 10 amp power supply. My power supply is only 5 volt 6 amps. That's okay. I'm going to not worry too much about that. I'm going to set my current limiter though to 6,000 milliamps. We have a 5 volt LED voltage, which is good, and our LED outputs, I am going to choose SK6812, and we are on pin number, I believe it's pin number 8. We can change that later if it's wrong. Now it looks like we also have the ability to change some other details here. We may actually be able to drive multiple LED strips from a single instance of WLED. Now that is very, very interesting. I'm looking forward to building something that does that. That's very cool. So we can see that our LED memory usage is about 720 bytes, so that's fine. And we can change things like our button pin, our infrared pin, if we had infrared there. When we've got -1 in there, that just means that it's not connected. What I do need to put in here is our relay pin, which is pin 7. And I'm going to turn off active high. I believe the way my FET is wired up, it's active low. So again, we can change that later on if that is wrong. I don't think we need to change anything else there. Good news is it says that 3.5 amps is going to be enough for most effects. I'm going to save that config, and it's telling me that pins 6 to 11 can't be used. So that's a problem if I can't use the pins that I have defined. Let me double check. Okay, so I'm going to set this to pin 13 and this to pin 15. According to the reference, that should be the GPIO references. I'm going to hope that that is correct and that I'm not going to be nobbled by this version of WLED. So we'll hit save, and it's saving those LED settings. And what I'm going to do is unplug the NodeMCU and then plug it into my control board there. and then I'm going to go and wire up the LED strip to this header here, and hopefully we should be able to get some light out of it if we add power. Okay, so I'm back now. Rather than continue to dig through the WLED code for hours and hours and hours, what I decided to do was a quick and dirty hack on the hardware. So what I've done is I've soldered a jumper wire to the LED signal pin that's the center of the output screw down terminals here, and also to the gate pin of the MOSFET, which should be this end of the MOSFET here, and I've just soldered those across over to meet up with pin 3 and 4 on the NodeMCU. Now the good news here is that if pins 3 and 4 don't work, I should be able to just move these around until I can get them to work. So I'm going to reflash my NodeMCU from install.wled.me, and we'll go with the 12.0 version and we'll install. I will make sure that that is connecting. So there we go, we've got USB serial, and we'll connect. It's initializing, and we will reflash it, and then we will have another go on pins 3 and 4. And then if I go back over to WLED settings, so it hasn't picked it up just yet. We're still on the WLED AP, and we've just cut back over to my regular Wi-Fi. I'll give that a couple more seconds just while I remount my control board in the mounting box. Okay, so I've got the control board in the mounting box. I'm just going to connect the LED strip now to the control board. Okay, so back over on the laptop, we've got our config. I'm going to go to LED preferences. Our LED count is 180. Our brightness limiter is 6,000 milliamps. 5 volts, we are using SK6812s, and we are on pin number 4 for the, pin number 4, I'm pretty sure is what I soldered it to. So we'll add pin number 4. Relay pin was pin 3. And I'll leave the box ticked. We can fix that later if we need to, and I'll hit save, and we'll go back and nothing. So I'm going to go back to config LED preferences. I'm going to turn that off, hit save, go back, and still got nothing. D3 and D4, so GPIO 0 and GPIO 2. Alright, so let's try config LED preferences. Let's try pin 2 and pin 0. Save. Back. I'm going to reset the strip, and it looks like we've got power. Okay. So it looks like we just had to reset the NodeMCU after getting the pin settings right. So if I go to green and blue, and we'll go to this kind of magenta color, so that's all working fantastically. If I go to effects here, I can go to an Android effect. Go to a chase flash effect. Brilliant. Chase random. Excellent. All right, so the LED strip is now working, and everything is working as I needed it to. For whatever reason, it didn't like the other pins, but we've got it working on pin 3 and 4, D3 and D4, which are GPIO 2 and GPIO 0 on the NodeMCU here. So I'm just going to turn the power off. That's all worked. Great. So the LED strip is now working, and I can confirm that all of the LEDs are lighting up all the way to the very end of the strip. So now I need to mount the strip up on the underside of the cabinets, making sure that the control wires are going to be at the end closest to where I want the power to come into the strip. But before I do that, I'm going to peel off the sticky back off the LED strip and push it down into the channel to stop it wiggling around. And then I'm going to clip the diffuser back into the channel. And then I'm going to mount the control box onto the side of the cabinet with some Gorilla double-sided tape. And I'll also mount the power adapter in the same way. And of course, I will be testing the strip to make sure that it's working after moving it around. Okay, great. So we've got the LED strip wired up, working with WLED. It looks great under the bar behind me. I'll be sure to turn all the lights off a bit later on so that we can actually get a really good sense of how it's going to look when it's actually being used, and I'll be sure to shoot some footage of that for you, and it'll probably be overlaid right now as I'm speaking. But now that that is all done, we can now head over to our Home Assistant instance and we can get it set up in Home Assistant. So I'm just going to open up my terminal here, and I'm going to open up HAS test, which will launch my demo instance of Home Assistant, and we should be able to go to notifications. So we'll dismiss these notifications, but what I am interested in is the new devices discovered. So I'm going to hit check it out, and we should have in here WLED 9DED9C. Now I'm pretty sure that's the one, the host name we had before. So I'm going to hit configure on that. Do you want to add the WLED named 9DED9C to Home Assistant? I'm actually going to not do that just yet. What I'm going to do is go back to my other Edge window, and I'm going to go to config, and I'm going to go to our Wi-Fi setup again, and I want to change this MDNS address to WLED bar. So I'm just going to set that to WLED bar. I'm going to save and connect. This is going to reset the WLED instance. So we'll go to config, and I'll go to user interface now, and server description is going to be WLED bar. I'll save those changes. Your Home Assistant will refresh this page. Look, it's still saying 9DED9C. That's okay. I'll hit configure and we'll submit that, and it's figured out that it's now WLED bar. It's free open source software WLED. I'm going to select an area, and this is definitely in the dining room here, so I will hit finish, and we now have that over here. This integration is WLED. I'm going to click on one device, and we see that we've got WLED bar here, and I can open up the details. So you see that we've got the configuration items. So there's things like intensity and speed, and we've also got sync receive and sync send. I'm going to open up the control panel for the LED, and I'm going to turn the effect to solid, and I'm going to turn the color brightness down to nothing and the white brightness up to full, and you can see that we've got a really lovely white color there, and if we put the strip brightness up to full, that pushes that up a little bit further. We can change the color to a nice blue. Now this is pushing the blue and the white LEDs at the same time, so I can bring the white brightness down, and then that should bring the LED strip back to just a regular blue color. And we've also got red, obviously, and green. So all the same things that we've seen in WLED before, and we can view the attributes as well, see the intensity and things there. And as with all WLED instances, we have a boatload of effects that we can play with here as well. So we can go police all, and that's going to do a nice kind of blue and red chase. We can do, I particularly like rainbow, and that does that rainbow fade right across the LED strip. There's a Cynlon, which is very similar to if we set that to red. Okay, so that is an update on WLED version 0.12, including using ESP web tools to install it from a browser and setting it up with a 3-meter LED strip under the cabinets behind me. I'm not super happy that I had to modify my control board in order to make this work. That being said, that control board was designed based on the old custom firmware that I'd modified in order to suit my needs. I'm hoping to complete version 2 of the control board at some point this year, and if you guys are interested in a custom control board to mount a NodeMCU to do stuff like this, then I will make those available for you as well. The updates to WLED and ESP web tools make the installation and configuration of WLED now so much easier. And the config now is all within the web interface, instead of having to then go and recompile the firmware to customize the setup for your LED and relay pins. I'm so happy to have this project completed, and it's going to add so much more ambiance to the bar area behind me. And because of the SK6812 LEDs with the white output, I can use the LED strip while preparing a cocktail on the bar behind me if I need extra light. That is all the time we have for this video, and I do hope that it helped you in your home automation journey. Be sure to comment down below with home automation ideas that you'd like to see me cover in future videos. Don't forget to follow HiveMind Automation on Twitter, Instagram, and Facebook. Links to those are in the video description. If you like this video, hit the thumbs up button down below to give it a like, and if you're not already subscribed, please consider subscribing now. While you're at it, take a second to hit the bell icon so you get notified when I release new videos each week. In order to help to support the channel, I've partnered with NordVPN, and there's an affiliate link to sign up for NordVPN in the video description down below. I chose to partner with NordVPN because they've got the best infrastructure of any of the VPN providers I've researched, and they have a strict no logs policy with servers all over the planet. And on top of that, they've got apps for just about every platform around, including Windows, Mac, Linux, iOS, and Android. So no matter what platform you're using, you can protect your information while you browse the web, whether you are at home, in a coffee shop, or traveling. So if you're looking for a VPN, use my link below to sign up for NordVPN. Lastly, if you like what I'm doing here, but you're not looking for a VPN provider, I've put a Buy Me a Coffee link in the video description down below as well. And contributions through the Buy Me a Coffee link will be used to make more and better content for you to enjoy. Thank you so much for watching. I'm Stu from HiveMind Automation, and I'm looking forward to seeing you in the next video. Bye for now.